Okay, today's question is 1249 minimum remove to make valid parentheses. So we are given a string of open and closing parentheses as well as lowercase English characters. Now our task is to remove the minimum number of parentheses such that the resulting parentheses string is valid, and we could return any of such valid strings as long as the number of removals were made are minimum. So the definition of a parenthesis or string be valid is that it could be empty or contain only lowercase characters, so there's no open and closing parentheses. Or it could be a concatenation of two valid strings. And the third case, it could be a valid string that's being enclosed by matching open and closing parentheses. So yeah, this definition is quite recursive, but the big idea is that there should be no dangling parenthesis symbols or characters within the string, and any of the open parentheses must have a matching closing parenthesis to the right of that, and any closing parenthesis must have a correspondent opening parenthesis to the left of that. So the example here we have Leetcode with open, open, closing, 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 two open, three closing, and either one of these three closing parentheses can be removed to make the result the valid string, and the number of remove is the same. Just remove any one of those. The second example we have closing, open, closing. So this one close nothing. It's an extra. We need to remove that. Here we have closing, closing, open, open. This two close nothing. This two cannot be closed. So remove all of those four. The last example we have open, 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 closing, closing. So we need to remove one of these three open parentheses to have the remainder be able to match each other. So for this type of question, usually it's good to use a stack. So when we see open parentheses, we just push the location of the open parentheses onto the stack. And when we see a closing parentheses, we'll check whether we have anything on the stack. If we have something on the stack, meaning that we can the closing parentheses can actually close that parentheses, we'll just pop the element from the stack. If the stack is empty, meaning that the closing parentheses can close nothing, then we remember the location of that particular closing parentheses, and indicating that in some final step we have to remove that character from the string, or when we see if we process the string with this stack in the end, and there are still some stuff left over on the stack, that means those items are the location of the unclosed open parentheses. So we have to also remove those as well. So just with one stack and one linear scan through the string, we will be able to figure out the locations of extra open and closing parentheses. And if we just remove those, we are fine. I guess it's a linear time algorithm, but the space complexity is a little bit more. It's using a stack to keep track of potentially linear number of open and closing open parentheses, the location of open parentheses. So if you are asked to write a constant space auxiliary to space solution, then you might need to do two paths, which is to just scan the string once to figure out the capacity you have. The number of by capacity I mean the number of closing parentheses, indicating the number of open parentheses you can close. Just keep have that counter stored. And the second time you scan through the location, when you see the lowercase English letters, you push that letter onto a string builder. When you see open parentheses, you increment a counter for the number of open parentheses that you need to close, and just compare that counter with the capacity you have. And by comparing that, you can figure out whether the open parentheses should be removed or not. And of course, this third case is that when you encounter closing parentheses, you need to decrement the capacity and do a comparison of checking the number of open parentheses you need to close out as well to figure out whether that closing parenthesis is actual or not. So that's the logic. If you do that, it will be 2 paths. So it's order of 2n, but 2 is constant. And for the space, you just have 2 counters. So that's if you for another discussion, we're talking about the auxiliary space, not the final space for building the upper strings. Using stack is just a little bit more than this 2 counter, 2 accumulator counter method. So let's code the second approach. So we have a placeholder collection to hold the characters. We need to concatenating to build out our final solution. We'll do 1 pass to calculating our capacity. Is equal to s.count, the number of closing parentheses we have. Then the open accumulator here is just 1. For character in the string, we're doing the second pass now. If the character is a open one, we need to increment the open accumulator. Otherwise, let me lay out the bare bone first, then handling the remover after the bigger picture is laid out. If the character is a closing parenthesis, then we need to decrement our capacity, and we need to, if we can have some open parentheses to close, we need to decrement that as well. And if it's lowercase letters or the parentheses shouldn't be removed, we append that to the result. In the end, we're just concatenating everything that we have on this result list. So the cases we have here is that if the unclosed parenthesis has already equal to our capacity, then this particular open parenthesis is one of the extra ones. So we need to remove this one. In order to remove this one, because we remove this one, we are not going to increment this, and we are not going to put that onto the result. So we just skip this iteration. And for here, we check whether we have any unclosed open parentheses. So if we have no unclosed open parentheses, then this particular closing parenthesis we have we are dealing with right now is one of the extras. So because it's extra, we are not going to decrement the number of open parentheses, because that if we do that, we just made this to be -1, which is meaningless. And we also want to skip this appending the closing parentheses onto the result. So we just skip the iteration. So with this, it's a 2-pass algorithm, and we're using only 2 integer variables. Yeah, so this is the solution. Let's try to submit it. Okay, it works. And yeah, so this is the question for today.